So now we're going to talk about the number of moles of elements in a formula. So you can see that aspirin here, the formula is C9H8O4. And so you have 9 carbons, 8 hydrogens, and 4 oxygens. So now we're going to figure out how to calculate each of the different molarities. So as you guys know by now, the subscripts in a formula show the relationship of number of atoms in the formula and the moles of each element in 1 mole of a compound. So 1 mole of a compound would have 9 moles of carbons, 8 moles of hydrogens, and 4 moles of oxygen. Another way you can look at that is 1 molecule is 9 atoms of carbon, 8 atoms of hydrogens, and 4 atoms of oxygen. So they are interchangeable in this one. So the subscript is used to write conversion factors of moles of each element in 1 mole of a compound. So for 1 mole of aspirin, C9H8O4, the possible conversion factors would be either you can have the moles on top or the moles on bottom. So you can see these two are the same, it's just whether or not you want the moles on the top or the moles on the bottom so that they can cancel each other out. So setting it up, let's state the given and needed quantities, write a plan to convert the moles of a compound to the moles of an element, write the equalities and conversion factors using the subscripts, and then write the problem, set up the problem to calculate the moles of the element. So let's practice. How many atoms of oxygen are in 0.150 moles of aspirin? And the formula for aspirin, again, is C9H8O4. Okay, so the solution would be, again, let's state what's needed. We're given the mole and we need the atoms. So how are we going to set this up? We have the subscripts to document the moles of oxygen, and then we're going to need Avogadro's number to calculate the atoms of oxygen. So let's set this up. So again, we have the 1 mole is C9H8O4, so that would be 4 moles of oxygen. Remember, Avogadro's number is 6.02 times 10 to the 23rd, so you'd set it up either with the atoms on top and moles on the bottom for either of these so that we can cancel it out. So how to solve this? Well, we have the 0.150 moles of aspirin. So we want to have it so that we have the moles of aspirin to cancel out, and we have 4 moles of oxygen on the top, and then how many are Avogadro's number for 1 mole, so we'd end up equaling out 0.150 times 4 times 6.02 times 10 to the 23rd. So that ends up giving us 3.61 times 10 to the 23rd atoms of oxygen in aspirin. So what is molecular mass in calculations? The molecular mass of an element is useful to convert the moles of an element into grams or from grams to mole. So for example, 1 mole of sodium has a mass of 22.99 grams. So what we're going to learn now is to calculate the molar mass of a substance given its chemical formula and using the molar mass to convert between grams and moles. The molar mass is the mass of 1 mole of an element and the atomic mass expressed in grams. So 1 mole of carbon would be 12.01 grams. 1 mole of lithium would be 6.941 grams. Okay, and so we get to practice this a little bit more and calculate molar mass. So again, we know molecular weight, etc., from the periodic table. So what they're going to do in this text is they round the molecular mass to the nearest tenths of a gram or place to use at least 3 sig figs for the calculations. Okay. So here's our handy dandy little guide. We're going to obtain the molecular mass or the molar mass of each element, multiply each molar mass by the number of moles that's in the subscript in the formula, and then we're going to calculate the molar mass by adding the masses of the elements together. So let's calculate molar mass of this formula. So lithium carbonate is used to produce the red color in fireworks for a fun little fact. So what are we going to do? Let's analyze the problem. So given the formula, we're going to need the molecular mass. So let's break it down. We need to obtain the molecular mass for each element. So for lithium, it's 6.941 grams per mole. For carbon, it's 12.01 grams per mole. And for oxygen, it's 16 grams per mole. So let's set it up so that our moles of lithium are going to cancel each other out, and then we can calculate. We have 2 moles of lithium from the subscript here, right, times 6.941 grams of lithium equals 3.88 grams of lithium. 1 mole of carbon, because there's no subscript, is 12.01 grams of carbon. 3 moles of oxygen times 16 grams equals 48 grams of oxygen. So let's do this now, and we're going to calculate the molecular mass by adding them together. 13.88 plus 12.01 plus 48 ends up giving us 73.89 grams for 1 mole of lithium carbonate. So let's practice. So let's calculate the molecular mass, or the molar mass, of C2H6O0, okay, or O1. So pause me and come back. So we're going to analyze the problem. We're given the formula and we need the molar mass. So let's look at the periodic table and figure out what it is. 12.01 for carbon, 1.01 for hydrogen, 16.0 for oxygen. And so then we're going to set it up so that the moles are going to cancel. We have 2 times 12.01 grams gives us 24 grams, 24.02. 6 times 1.01 gives us 6.06, and 1 times 16 gives us 16. So what is the solution? We're going to use this to calculate, and then we're going to add them together, and that gives us the 1 mole of C2H6O equals 46.08 grams.